So yesterday we started our first little two's clues problem, and it was pretty easy because the second clue told us directly which quadrant the angle was going to live in. It said between 90 degrees and 180. There's nothing mysterious about that. But on example 4, it's not quite as explicitly given, but it's still enough information. So here's what this one says. If tangent of some unknown angle theta is 5/12, and cosecant of that same angle theta is less than 0. There's your two's clues. Determine the simplified exact value of the other 5 trig functions. Okay, so just to remind you, when you have a trig ratio such as 5/12, those two numbers in the numerator and denominator give you the ratio of what? What does a trig function actually give you? Side lengths, very good. 2 of the 3 side lengths of a right triangle, which means you can always find the third by the Pythagorean theorem. R is always going to be positive, the hypotenuse, but x and y can be negative. So you do need to figure out which quadrant you need to be in case you need to find x and y to be positive or negative. So here's what we're going to do. Based upon the first clue, which gives us the actual value of the ratio, 5/12, the theta with a positive tangent ratio could live in which 2 quadrants? Just on the first clue, it could be in quadrants 1 or 3. Good. Because remember, tangent is y over x, both of which can be positive or negative. So you're going to have a positive tangent ratio when x and y are either both positive, which would be in quadrant 1, or when they're both negative, right? Because the negative divided by negative is a positive, so in quadrant 3. So based upon that first clue, we don't know which of the 2 quadrants we actually want to be in. Your calculator, remember as we saw yesterday, is only going to give us an answer in 1 quadrant every single time. And which one do you think your calculator will give you? Just looking at that before we get to the calculator. Quadrant 1. Your calculator always gives you the angle in what you can think of as the most convenient quadrant. Okay, so here's the second clue. It tells us that the cosecant ratio of the same angle is less than 0. That means it's what? Positive or negative or 0? Negative. So in which 2 quadrants is cosecant negative? Cosecant is negative in which 2 quadrants? Cosecant is negative when sine is negative, right? Because cosecant is r over y. R is always positive. So y is negative in quadrants 3 and 4. Yeah. And so you're going to have an overlapping quadrant from the 2 clues. So there's only 1 quadrant that satisfies both of those ratios or signs of ratios, and that's quadrant 3. So there you go. We know that our theta must live in quadrant 3. So once you know that, then go ahead and draw a generic terminal ray. Again, I always like to draw it on the 45 just because it makes it easier to label. And then you're going to want to create a reference triangle. You create a reference triangle by drawing a line to the y-axis, question mark? No, I've seen that. That's not right. You draw it to the closest x-axis. So in this case, you're drawing it upward. And the reference angle is going to be that little green angle right there. Okay, so now that we have the triangle drawn, we can label 2 of the 3 sides that were given. The tangent is y over x. And so we can label the y as 5 and the x as 12. But is that correct? They're both negative. Good. -5, -12. So you are in charge of assigning them the correct SIGN sign, depending on the quadrant in which they live. And now that we know the 2 side lengths, we're looking for the radius. Now, the radius or the hypotenuse always has to be positive, and we're going to use the Pythagorean theorem. So we know that r squared is going to equal -5 squared plus -12 squared, and that means r is the positive square root of 25 plus 144, which is the square root of 169, which... is that a perfect square? That's 13, yeah. And r is the only one that's always positive. So we don't even need to consider plus or minus there. So it's your old 5, 12, 13 Pythagorean triple. And if you recognize that right away, you would be able to avoid the Pythagorean theorem. And of course, now that you have the side lengths of all three sides, how many trig ratios do you have, essentially? All 6, okay? And it's just a matter of listing them. Now, I always like to list them in a complete set, so I'm just going to go ahead and list them all again. Sine of theta, cosine of theta, and I know we already have tangent of theta, but I'm going to list it again. And I'll list the SOHCAHTOA ones first, and then over here, the reciprocals. And I like to list them in reciprocal pairs because, again, it reinforces it. The reciprocal of sine is cosecant, and the reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. So if you want to go ahead and write the definition of each of them in terms of x, y, and r, you could do that as well. All right, let's go ahead and pull the ratios then off of the triangle. Sine is -5 over 13. It's y over r. What's nice is none of the side lengths have a radical in them, so we don't have to worry about rationalizing. Cosine is x over r, so that's -12 over 13. Tangent is y over x, which if you want to verify, that's -5 over -12, which is +5/12. Good. And that's the one they gave us, and we got the same answer, so that's awesome. Cosecant is r over y, so that's 13 over -5, or just -13/5. Doesn't matter if you put the negative in the top or bottom. You know why it's negative. It's not because of r. Secant is r over x, which is -13/12. And then finally, cotangent is x over y, which is -5 over -12, or, I got that backwards, -12 over -5 is +12/5. And now if you want, you can compare your column on the right to the column on the left and make sure they are, in fact, reciprocals. Once you get really, really good, of course, if you have the sine, cosine, tangent, you could just flip them. Knowing that they're right, you could just flip them. But it's always nice to be able to pull them off of the triangle as well. Easy enough? Yeah. So now we're going to do what we did yesterday. We're going to actually find what theta is. And so we've created 6 little equations with an independent variable theta, and all we have to do is solve any one of the 6 that we created. But of course, the second column we try to stay away from because there's no cosecant, secant, or cotangent button on our calculator, although there is a way to do it. There's a few more keystrokes. So maybe something from the first column. What would you like to choose? Tangent? Tangent's probably the wisest of the 3 because it's the one that was given. Yeah. All right, so let's go ahead and do that. You don't have to show taking the inverse tangent on both sides, but here's what you would have to show. Theta equals the inverse tangent of 5/12. Now, do we want our degrees, or our angles, in degrees or radians? Does it matter? It sure does, right? So if you look in the question, it'll give you a hint. Here's the hint. Theta is going to be an element of 0 degrees to 360 degrees. So we need to be in what mode? Degrees. All right, so I'll show you the keystrokes again. And with any luck, the calculator will not give us the actual angle we want so that we have some more work to do and some more fun to be had. All right, so I'll go ahead and type in now inverse tangent of 5/12 after I check my mode. I'm in degrees, so that works well. Second tangent. That's not the reciprocal of tangent, that's the inverse tangent. We take inverse trig functions of ratios to find angles, and we take trig functions of angles to find ratios. So this is going to give us 22.619. So theta on my iPad, I'm going to write 22.619 if you truncate, or 620 if you round. You would need that trailing 0. Now, can that possibly be our angle? No, no way, because our angle is in quadrant 3. Now, the calculator doesn't know that. We just told the calculator to give us an angle that had a positive tangent ratio. Tangent's positive in quadrants 1 or 3, as we already saw, and we knew that it was going to give us the one in quadrant 1, or y'all said that already. So how can I use the calculator's answer to find the one I want? Add 180. Yeah, very good. Because as I mentioned yesterday, the calculator may not always give you the angle you want, but the reference angle of the calculator's answer will be the reference angle of the one we want. So 22.619 being a positive acute angle is the reference angle. So you can actually label that as the reference angle. Now, how do you know to just add 180? Does that work for all trig functions? If you're off, just add 180? No. But if you haven't noticed already, tangent and cotangent are always going to be in opposite quadrants from each other. So quadrants either 1 and 3 or 2 and 4. And they're always going to have the same reference angle. So tangent and cotangent, the two possibilities are always going to be 180 degrees apart. But what works in general as well is if you know what the reference angle is, you can actually look to see what your picture says to do. Your picture says to go all the way to 180 to the negative x-axis plus the additional amount of the reference angle. So it is going to be just that plus 180. And of course, if you add 180 to that, can we do that without a calculator? Sure, I hope so. What do we get? 202.619. Now I'm going to put my degree bubble on so I don't lose points at the end. And there you go. Now I would invite you to do one last thing here before you just walk away from the problem. If you add 180 to it, you get that angle there. You could store it as x, and then maybe just verify one of the other ones that you found. Like we found sine to be negative 5/13. Let's see if the calculator knows that. First of all, negative 5 divided by 13 is this as a decimal. Let's see what sine of the angle x that we stored is. How do they look compared to each other? Same. That's pretty good indication that we are awesome. Yeah, and correct. Yeah, and awesome. All right, remember yesterday when we used the cosine? Remember the cosine one gave us the actual angle that we wanted? I wonder if it does it again here. Let's try it one other way. What if I took the inverse cosine of negative 12/13? You think it's going to give me the angle I want? I don't know. If we're telling the calculator to give me an angle whose cosine is a negative number, in which two quadrants is cosine negative? Cosine, remember, is x over r. R is always positive. So cosine's negative when x is negative, which is quadrants 2 and 3, jazz hands. So do you think the calculator is going to give us an angle in 2 or 3 or 2 or 3? 2, because 2 is easier to get to than 3, right? So the calculator is not going to give us the angle we want. But let's see. Let's see we choose that. Is there a way to still get the answer we want? I hope so. Inverse cosine of negative 12/13. Hey, 157.380. That guy lives in quadrant 2, you know. Yeah, he does. So can we just add 180 to that? We can get our answer? No, we can't. So remember what I said. If the calculator doesn't give you the angle you want, the angle it gives you and the angle you want will have the same what angle? Reference angle. So what you would need to do is find the reference angle of the calculator's answer. And because it's short of 180, you would go 180 minus the answer, and that'll give you 22.619. So now that you have your reference angle in your hand, you can look at your diagram and realize that, oh, I got to go that much past 180, and then you can get to your answer, which is the same one we had. So a little bit of fun or a lot of bit of fun? A lot of bit. Yeah, I agree. A lot of bit of fun. All right, I'm going to let you try the next one then, all on your own. Example 5. If cotangent of theta is negative 2 and cosine is greater than 0, same thing. Determine the simplified exact value of the other trig functions and then find the value of theta between 0 and 360. When you mark it, set, go. I mentioned that while you were gone. And our test is Wednesday. Don't forget your theta after the sign. There you go. When you're writing your ratios, don't forget your theta. Sine of theta without theta, not a crime, but it is a sin. And you'll lose points for it. Don't forget your theta. Sine of theta, cosine of theta, tangent of theta. You're not turning in any of your homework. Why is that? Are you doing it? Oh, yeah. It's not the way to go through this class. Because when you're not doing your homework, then you're not practicing on your own. When you're not practicing on your own, you're not doing well on any of the quizzes or tests. Okay? You can't just watch me do it and agree with me. You have to do it on your own. What instrument do you play in band? Clarinet. Oh, that's right. We talked about that. Yeah. Miss Thompson and your band directors, they kind of want you to do what on your own? What's it called? It's the P word. There you go. Practice. And guess what the worksheets are in this class? Practice, right? So you need to make sure you're doing them, okay? Because it's affecting your grade ultimately, right? Don't forget your F theta. Second column, did it again. Do. Something similar to this again will be like on your pre-response question next Wednesday. If you know how to do it, it should be pretty fun, easy. I'll give you one more minute, and then we'll kind of go over it together, see how you did. Okay, so based on the first clue there, cotangent of some theta is -2. That's a ratio. Of course, it doesn't look quite like a ratio, so if you put it over 1, it looks more ratio-esque. And it's not any ratio, it's the cotangent ratio, which means you're staring at the ratio of x to y. So you can let x equal -2 and y equal 1, or you can let x equal +2 and let y equal -1, because x and y can be positive or negative. So based on that clue alone, cotangent's negative when x and y are opposite. That's going to be either quadrant 2 or quadrant 4. Negative x positive y or positive x negative y. And then it says that cosine is positive. Cosine's positive when x is positive, which is quadrant 1 and quadrant 4. And of course, then the overlapping quadrant is quadrant 4. So that's the first step. You know your angle is in quadrant 4. So you draw a generic terminal ray into quadrant 4. You create a reference triangle by drawing a perpendicular to the x-axis, and now you can label the sides. And if you're not thinking, you might label that as -2 and 1. Yeah? Is that correct, though, like that? That's going to mess up a lot of your ratios if you do that. It's not -2 and 1. It's actually +2 and -1. So always be mindful of which quadrant you're in. Now, by the Pythagorean theorem, did you keep it as -2 and 1? Oh, okay. That's another way you can go wrong, right? You get the definition backwards. So we've got those three values, and now we can list them all. So sine of the angle theta, again, don't forget your theta. It's y over r, which is -1 over the square root of 5, which when you simplify is -5/5. Cosine of theta is x over r, which is 2 over the square root of 5, or 2 square root of 5/5. Tangent is y over x, which is -1 over 2, so -1/2. And then working on the reciprocals here, cosecant of theta. Here's where you don't want to just flip your rationalized answer, -square root of 5 over 5, because then you'll have to re-rationalize. So if you know this answer is right, flip the unrationalized version, and you just get -square root of 5. Or just pull it off of your triangle again. Square root of 5 over -1. Secant of theta is going to be the square root of 5 over 2. And cotangent of theta, just for check purposes, is x over y, which is 2 over -1, which is -2. So there they are. There's all 6 of them. All right, so we get to choose really any of the 6 to find our angle theta. The cotangent one was given to us. I don't think I'm going to want to use the one that was given to us. So which one did y'all choose? Tangent would probably be the next safest because it's the reciprocal of the one that was given, so it didn't really require you to find a value like 5 or square root of 5, and it also doesn't have a radical. So yeah, if we take the inverse tangent of both sides, we'll get theta equals inverse tangent of -1/2. Now let's think about where the calculator is going to give us our answer. Tangent is negative in which 2 quadrants? 3 and 4. You mean 2 and 4? Oh, yeah. Yeah, 2 and 4. And which of those do you think the calculator is going to give us our angle in? Actually, quadrant 4. You might think 4 is further away than quadrant 2, and it is if you rotate counterclockwise every time, but the calculator is very efficient. It realizes that quadrant 4 is closer than going all the way to quadrant 2. So it doesn't care if it has to rotate to negative land to get there. So it's going to give you a quadrant 4 angle. Do we want our angle to be in quadrant 4? Oh, so it might give us the one we want, huh? Maybe? I don't know. My mouse is over here. I moved it for convenience. All right, so let's go ahead and type it in. The inverse tangent, second tangent of -0.5, same as -1/2. -26.565. Is that the angle we want? That's in quadrant 4. We want our angle in quadrant 4. Is that the answer? Not quite, because we do want our angle to be in quadrant 4, but notice it says we want it to be between 0 and 360. So the one that the calculator gave us got to the same terminal ray, but got there by going straight down, which means it's what with the one we want? Coterminal. So all we need to do if we want to get our angle Since it's coterminal, is do what to this one? Yeah, you can add 360 if you want. So plus 360. If you know it's coterminal, you can add 360. And you get 333.434. Again, I'm a big fan of truncating. So theta is 333.434 degrees. Now, I'll always ask you to find the reference angle. What would the reference angle be? Positive 26. Good, 0.565. So you could have recognized that from the first answer right there, that it rotated clockwise, that's why it's negative, by an acute amount of 26. So the reference angle is 26. And then once you have your reference angle, you could say, oh, now I got to stop 26 of a full rotation, so it's 360 minus positive 26. Yeah.
My inverse tangent, I left it as a fraction, like 1 over -2, and it gave me like -26. I mean, it gave me like -11.
That's not right.
So I just always do it like that, like with like half or something.
No. It should still give you the right answer. I'm just wondering how you typed it in. Did you close parentheses too soon? Sorry, that's not it. Inverse tangent, you hit second tangent of, you did 1 over -2? All right, just like that? All right, that should give us -26.565. Yeah, I think you typed it in. Maybe you closed parentheses too soon, or maybe you didn't put a negative, or are you in degrees?
Oh, never mind.
Yeah, that's another big thing. We haven't changed the radians yet, so if you got it right on the previous problem, it should still be in degrees. But that's another thing to always check for. And it's kind of cruel, but on a multiple choice portion of an exam where you have your calculator, I tend to put the correct answer that is in the wrong mode. So if you do everything correct, but you're in the wrong mode, you'll see your answer there. Oh, awesome. Ain't you, buddy? Okay, we'll finish the notes pretty easily on Monday, which means your worksheet will be due on Tuesday, okay? So make sure it doesn't sneak up on you over the weekend.